Okay, so it's been a while since I've shown you an update to the system. But since I've shown, I've got the system up and running with two panels now, 235 watt Conergy panels. They are hooked in parallel so that my voltage stays the same coming in, but the amps that are produced are actually more. So outside right now, there's no direct sunlight on the panels. They're still generating 1.3 amps, which you'll see right here as we zoom in. So you got 1.3 amps of juice being generated. I've got the entire system really turned off and sitting on idle, so the only thing happening is the charge controller is topping off the batteries, and it's not getting a deep enough charge yet to where it's really cycling a deep charge. It's just putting some juice into the system, and you would be able to tell by the light there on the right on the charge controller would be blinking, but it's a solid green light, which means it's just receiving a charge. So with that, I'll go ahead and show you outside real quick here what we got. And take you outside. And so we got plenty of sun. And what we got down there are two solar panels set up on a wooden stand I made, a wooden frame. And I've got my trench back here. I've got to bury my line, which in itself in Phoenix is 115 degrees. I don't mind my aluminum cans, gotta recycle those. But I've got this trench dug, and here in Arizona it's common to have the cable guys just throw your line right here on top of the ground, which is a bunch of crap, but I'm digging my trench, we chopped right through one of those. So in here I'm going to run it up into the house. The small gauge, low gauge wire that's used for lighting that has a high outside UV value and resistance. So with that not getting any direct sun to those panels yet, we're still drawing 1.3 amps, which is pretty impressive. So, and then when we kick on the inverter, we'll see our amps drop down. This inverter is using about 1 amp to function. And then I've got some fluorescent lights set up, extension cord running around to run here. So if I flip my lights on, see the juice from the battery get taken down even more. So now I'm no longer producing a charge, I'm taking away from my system. But I get the energy, the benefits of having solar right there. And then I'd be able to turn this bad boy off, which is currently still hooked up to the house. So ultimate goal is to get everything in the garage running here on these batteries, which is currently a bank of 4 6-volt batteries, golf cart batteries. I've got 105 minutes, 75 watts or 75 amps each on these batteries, and I've got 2 of them hooked in parallel, and then the 2 in the center there are hooked in serial. And then I've got a negative feed here feeding into the system, which runs all the way up and into my shunt, and then all my negative leads that are being used on the system to the right side of that shunt. I had a hard time learning all this on my own. I didn't have any really helpful videos on installing this TM2025A trimetric system, which is a really cool monitoring system, but the videos and the explanations were not that helpful. So I'll give you a quick rundown of what I got here. The shunt and this monitoring system work in tandem with each other. It's really you got to be very careful about how you wire this thing together. In prepping my installation, what I did was I kind of had an idea about where I was going to try to place everything. Didn't work perfectly, but I had to move some stuff around, but I had the right idea. So what I did was I pre-cut all my wires, and the TM Trimetric system tells you to use 4 unique colored wires so that there's no way of misunderstanding where these wires are going to go. But if you look at the back side of the Trimetric, it's got a series of pins, and I'll show you here. These pins on the actual documents that you get are labeled as G1, G2, SIG, B1, and B2. Well, with the 2025 Trimetric, you're allowed to operate and monitor 2 different battery banks, but in my case I'm only using one. So what I did was I went through here and I methodically said, okay, I'm going to use somewhere around here on my notes I made. I was going to use these wires for my system, so I went ahead and pre-cut all these wires. So my G1 and G2 go to the right side of my shunt and hook up to the Kelvin connection up there on the top. There's 2 connections on the top on the shunt here. You got one on the left hand side, Kelvin connection, which are these little connections at the tops. So the ones on the right are the G1, G2 connections. The SIG is the connection there on the left. Those are both Kelvin connections. Those just monitor a small voltage drop, and that's how the Trimetric system is able to read it. And then my B1 cable is yellow, and it runs down into a quick blow 1 amp fuse, which I picked up at regular auto dealership or auto shop, and it runs down into the positive lead of my battery. And then from your negative bank, I've got a standard 4-gauge wire that runs up and directly into the left side of the main shunt bolt. And then again, everything else that I'm drawing any current from goes to the right side of the shunt. And then the system's able to read. So it's not as complicated as it appears when you're first looking at it. And of course, all the major warnings, you got to do it procedurally correct, because you do stand a chance to blow your system and or your batteries, which you don't want to do. So I do encourage you to read the directions thoroughly and take the proper instructions and heed them with warning, because you don't want to blow your equipment, because it all adds up in price, as you'll find out when you do this on your own, if you do it on your own. And you know, I'm not doing this probably exactly as I should be, but I'm learning as I go. And one other thing, the Trimetric 2025A, when you get this, this is not the RV version, it's the A. And when you get the A, it doesn't come with any kind of housing, which kind of surprised me. So what I ended up doing is I went to Home Depot and I bought a piece of 1/2-inch PV, which I'll show you here. Just standard 1/2-inch PV pipe. And I had 4 ends cut down to 1-inch pieces here. Just 1-inch little caps there. And then I went ahead and bought some plastic washers and just used an 1.5 inch wood screw. And I originally had 4 in there to hold it. It's working just fine. It's really stable. It ain't going nowhere at all. The one thing you do have to be careful about are the connections at the bottom. These wires, they don't stay very tight even when you tie them down pretty snugly. So you got to be careful, because they will pull out on you, and after you mount this, you don't have access to the heads to tighten the wires down, so you got to pop it off again and reattach them. But that's about the only part I had a difficult time with, and so that's where we're at. And let me turn my lights off. The only thing running now is my inverter, which is pulling an amp. So kill that, and now I'm back up to my 1.2 1.3 amp charge with no direct sunlight yet in onto those panels. I can't wait to see what that's going to produce. I'll show you that later. And that's it. Thanks.